So here we can put here equation 1, right, and this one equation 2. Okay, if you add both these equations, then here you will get a plus f equal to b plus e. Okay, which means that your a b is related to ef. Okay, so here you can see it how a plus d plus c plus f, which is equal to bc d e, right? So c got cancelled with this, d got cancelled with this, a plus f equals b plus e. So it says that if AB is related to CD and CD is related to EF, then AB is also related to EF, which says that your R is transitive, right? Your R is transitive. Now, see here, your R is reflexive, your R is symmetric, your R is transitive. So therefore, relation is equivalence too. I hope you understand the point. Okay. Uh, all right. Let's move to the last one. Okay, so the last question, it is also very interesting question. Let's see what it says. Question number 5 says that, question number 5, it says that your R is a relation defined as xy such that your xy belongs to the set of natural numbers and x square minus 4xy plus 3y square equal to 0. Okay, we have to prove R is reflexive but neither symmetric nor transitive. Okay, now this is given to us. Okay, so here I can say that our xy belongs to R, right? And which x and y's are going to be in the relation? Only those going to satisfy this condition. Okay, can we simplify it? Let's see it. Here x square minus xy minus 3xy plus 3y square equal to 0. So here x, here x minus y, here minus 3y, here x minus y. So x minus y, x minus 3y equal to 0. So x equal to y and x equal to 3y. Okay, so only those x and y that are going to satisfy these conditions are going to be in the relation. So from here I can say that from here I can say that either x equal to y or x equal to 3y. I hope you agree with me. Okay, now let's see that if it is reflexive. Okay, now reflexive relation. Okay, number 1, reflexive. Okay, so if it is reflexive relation, then according to the definition, it must be xx belongs to R for all x that satisfy, for all x here, for all x belongs to our natural number and for all those x that satisfies this. Okay, so here see here, if x is equal to y, okay, so if x is equal to y, then what would happen? Then let's say that if x is equal to 1, if x is equal to 1, then your y, if x is equal to 1, then y is also equal to 1. Okay, so see here, because x is equal to y, so if that happens, then what will be the case? Then your 1 1, it's going to be in the relation. Okay, if 1 1 it's going to be in the relation, then what it means that here R is reflexive, right? I hope you understand it, right? If your x is 2, then y is also again going to be 2, and then again 2 2, it's going to be in the relation. Next is your symmetric. Okay, symmetric means that if xy is in the relation, then yx must also be in the relation. Okay, now it's, and here x, either x equal to y and x equal to 3y. Okay, now right, now here see one thing, if x is going to be 1, right, if x is going to be 1, then what would happen? If x is going to be 1, see here, if x is 1, then y is 1, right? And from here, if x equal to 1, then y is equal to, sorry, if x is equal to 1, if y is equal to 1, then x is equal to 3, right? So this is fine, right? If 1 1 is in the relation, then if xy is in the relation, then y of x is also going to be in the relation. This is fine, right? But if 3 1 is going to be in the relation, okay, then what about 1 3? Is it going to be in the relation to 1 3? Now you can check here. 1 3, 1 3 is not going to satisfy it. Why? Because if you put y1, sorry, if you put x1, then y is not going to be 3, right? So which means that it's not going to be in the relation, right? So this is not symmetric. Why? Because 3 1 is fine, but 1 3, it's not going to be in the relation. Therefore r is not symmetric. I hope you understand. Symmetric. Okay, let's check for transitive. Okay, again, transitive says that if AB is in the relation, see here, so it has to follow this, x equal to 3y. Okay, if xy, it is in the relation, xy is in the relation R. Okay, and if yz, if this is in the relation and this is in the relation, then here y is equal to z, and y it's going to be 3z, right? And if both these things happens, then xz must also be in the relation such that x equal to z and x equal to here 3z, right? But let's see if this thing can happen, if this thing is possible or not. Okay, fine. If x equal to y and y is equal to z, then this thing is fine. This thing is fine. And if x equal to 3y and y equal to 3z, then your x is going to be 3y, which is 3 of 3z, which must be equal to 9z. So here it says x equal to 3z, which means that this is not going to be possible. So here, from here, I can say that xz, it's not going to be in relation R. Therefore, this relation is also not transitive. Okay, so this relation is only reflexive. Why? Because here it can either take up x equal to y or x equals 3y. Okay, and if you if you check for reflexive, then it's going to to show validation for the function to be the reflexive function. Okay, I hope you understand it, and in the coming times we are going to have a few more problems similar to this. This is little, would say that little, the difficulty factor is little high, but just if you don't understand anything, just watch it several times and think about it, because sometimes when you think about thing for for a short while or for a long while, then it clicks. Okay, so that's how you have to approach it. Thank you very much. I will see you next time. Bye bye.